Okay, this is the last video of the year. We're going to cover the lateral area, the total area, and the volume of cones, which we're going to think of as round pyramids, and spheres, which are kind of a figure all on their own. So I've got a PowerPoint with a couple of slides for you to go through. I just want you to focus on the formulas. You'll notice that cones are very similar to pyramids in the same way that cylinders were to prisms. That because every cone has a circular base, we can have a more specific formula than we can for pyramids, in the same way that cylinders had a more specific formula for area and volume than prisms were able to. Okay, let's continue our discussion with cones. As you can see from the pictures, cones really are just round pyramids. So the formulas for lateral area, total area, and volume are going to be similar to that of pyramids. Lateral area is going to be 1/2 the perimeter of the base times the slant height, just as it is for a regular based pyramid. But since the base is always a circle with a cone, the formula can be more specific, and the perimeter of the base can be interpreted as circumference, 2 pi r. So the 1/2 and the 2 cancel, and we're left with a formula for the lateral area of pi rl, where L stands for the slant height, or the height of the face of a cone. Total area is equal to the lateral area plus the area of a base. So we're going to bring down the pi rl to represent our lateral area, and then the area of the base will always be a circle, so that's just pi r squared. And finally, the volume will be 1/3 area of the base times the height, just as it is for a regular base pyramid. Since the base is always a circle, we get 1/3 pi r squared times the height. Now let's take a look at the last solid that we need to cover, which are spheres and hemispheres. For spheres, there is no lateral area, so we always just think of the total area of a sphere, and that's 4 pi r squared. The volume is 4/3 pi r cubed. The proof of these two formulas is well beyond the scope of this course, so we just have to memorize these two. So total area is 4 pi r squared, and volume is 4 pi r cubed. Finally, hemispheres. Because a hemisphere is half of a sphere, the lateral area is 2 pi r squared. But by cutting the sphere in half, we introduce this circular base, so the total area is 3 pi r squared. The volume is just half of a sphere, so 1/2 of 4/3 is 2/3, giving us a volume of 2/3 pi r cubed.